Okay, sorry, I was trying to figure out what happened, and hopefully I've uploaded the right copy now, or the right format. Okay, so here's number 4. The limit as x approaches 5 of x g of x, so that is our product rule, and that's going to be the same thing as taking the limit as x approaches 5 of x times the limit as x approaches 5 of g of x, okay? And now we already know this second one here that was given, that's 6. Okay, the first limit, we're just plugging in 5 for x, okay? That's all that's there is x. So this one's going to be 5 and then times your g of x, which was given to us as 6. So that'll be 30. Okay? All right. So when we have been finding limits, sometimes the limit was the same as the value. When this happens, direct substitution will work. Okay? For example, if we wanted to find the limit as x approaches 2 of x squared, it would be 4 because we're just directly substituting in 2 and getting 4. Okay? However, if substitution does not work, you must try other methods. So if you look at this example, if you plugged in -2, you would get 0 over 0, actually. Okay? Now, you would get 0 over 0 or undefined. Okay, so that does not mean the limit doesn't exist. That is not deity, which I know some of you were saying, and that's okay. But now that we're moving on, we're going to find other ways to still evaluate the limit. Typically, this means there's a hole in the graph at that value. And as you know, you can still have a limit with a hole, okay? So when this happens, we need to try a few algebra techniques. Let me scroll to that, okay? Either factoring, conjugate multiplication, complex fractions, or trig identities. And today we're really just gonna do factoring, okay? So let's look at this next problem, which is actually the same limit on that front page. Okay, because this can actually be simplified more. All right, so use factoring to simplify. Then use substitution to evaluate the limit, okay? And so if you're having issues with factoring, you may just need to start this problem or start these problems, and we can talk about it more in class, okay? But if we wanted to factor the numerator here, the denominator we can't. It's x plus 2. There's no way to factor that. There's no GCF there, okay? But the top is a trinomial, so we need to factor into 2 binomials. And how we do that is if you think of your -6, what are 2 numbers that times to -6 but add to, in this case, -1 is the coefficient of x, okay? So 2 numbers that times to -6 and add to -1, that would be 2 and -3, okay? And then when we factor with binomials, you want to have your signs, obviously, so this would factor to, it would factor as x plus 2, x minus 3. Okay, so that's equivalent to the top. It's just another way to write it by factoring. Okay, so the denominator doesn't change. It's still x plus 2. We're going to group it up so they look the same. Okay, and then we're going to keep simplifying because these 2 factors cancel. All right, so now all we're left with is the limit as x approaches -2 of x minus 3, okay? And now we can use substitution to figure that out. So we're just going to plug in -2 in for x. Okay, So when we take the limit, we use substitution, and it'll be -2 minus 3, and that equals -5, okay? So if you did not simplify this and just plugged in -2, you would get 0 over 0. All right, that's why it's important to simplify. Common factors cancel out, and then we substitute it in our value at the end. Okay, so let's do a couple more. Example 3. In this case, the denominator is what we can factor and simplify, and that's a difference of squares. So that's x squared minus 1. Technically, that's x squared plus 0x minus 1. So what are two numbers that times to -1 and add to 0? 1 and -1. Add those up, you'll get 0, right? So our denominator will factor to x plus 1, x minus 1. Okay, so sorry, this is the limit as x approaches 1 of x minus 1 over x plus 1, x minus 1. Okay? And so I'm going to put parentheses around the top binomial because those are going to cancel. Okay, and so we're left with the limit as x approaches 1 of 1 over x plus 1. Okay? And then that's our second step here, is to just plug in 1 for x, just substitute. So if you're plugging in 1 for x, you're going to get 1/2 when you evaluate that limit. Okay? All right. So the next one, you know what I forgot to do in the first one is check that if we plugged in 1, were we dividing by 0? 1 minus 1 would have been 0. Yes. Okay. So let's look at example 4. If we plug in 2 for x, are we dividing by 0? No. So this one, we can actually use direct substitution. Okay. So try that first, and I should have the last time, because it may work. Okay. And then you don't have to factor. You can just plug in. All right, so since we're not dividing by 0, breaking any rules of math, we can just plug them in. So that'd be 2 squared plus 5 times 2 plus 6 all over 2 plus 2. Okay, so that'll be 4 plus 10 plus 6, 20 all over 4. And that gives you 5. Okay? So that's kind of a difference between when you do have to factor and when you don't. You do have to factor when you're dividing by 0. Okay. 2 more, and we're going to actually save conjugate multiplication for the next lesson. Okay? So you'll see that show up on the next notes. All right, let's practice this, actually plugging in 1 first. And as you can see, yes, we would divide by 0. Okay, now for this actual problem, we have the top and the bottom, or the numerator and the denominator, are both factorable. So we have to factor both. Okay, and here's a hint. You should have a common factor cancel out. All right. So we just did x squared minus 1. We just factored that. And it was x plus 1 times x minus 1. Okay. And so hopefully on the top, one of those two will be a factor, or you really will have does not exist. Okay. So let's factor. Let me get a different color. Let's factor the numerator and figure out what that is. Okay, so I want two numbers that times to -6 but add to 5. Okay, so 6 and 1 could somehow give me 5. I want a positive 5, so that's going to be -1 and +6. Okay, so that's going to factor as x plus 6, x minus 1. That's a very basic, quick explanation of how to factor. Okay, so the x minus 1s will cancel here. All right, and now we can find our limit just by using direct substitution. So this is now the limit as x approaches 1 of x plus 6 over x plus 1. Okay, and so we're just going to plug those in. So let me just get a different color. 1 and 1. Substitute that in. And you should get 7 over 2. All right, one more. If you want to try factoring this by yourself,